Hello everyone, welcome to today's class. We are discussing 15 questions of general aptitude for GATE 2026. In our last class, we discussed 3 questions of probability as well as a practice question for probability. In today's class, we are going to discuss 2 type of topics, time, speed, distance and time and work. So let us start. The first question, please pause the video, give it a try and then you can cross check your solution with ours. A tiger takes 4 leaps for every 5 leaps of a deer, but 3 leaps of the tiger are equal to 4 leaps of the deer. So what is the ratio between their speeds? Okay, so we have got tiger and we have deer, and a tiger takes 4 leaps for every 5 leaps of a deer. This is the first information given. But 3 leaps of the tiger is equal to 4 leaps of the deer. This is the second information given. We want to find out the ratio between their speeds, right? So ratio between speeds is also going to be equal to ratio of the distances if the time is constant, right? Speed ratio equals distance ratio when the time is constant. The first line tells me that the tiger takes 4 leaps for every 5 leaps of the deer, right? So here we have been given the distance that they are covering in equal time. So I can take the ratio of the distances and that would give me the ratio of the speed. So if I want to find out the ratio of distance which is covered by the tiger and the deer in the same time. So suppose 1 leap of a tiger is represented by t. So 4 leaps of the tiger is going to be 4t and 5 leaps of a deer is going to be 5d, where I am talking about t as the leap of tiger and d as the leap of deer, right? So if I want to find out the ratio of the distances, I have been given that 4 leaps of the tiger takes 4 leaps for every 5 leaps of a deer. So whatever is the ratio of the distance that they are covering in the same time, 4 leaps of tiger divided by 5 leaps of the deer. In the same time, the tiger is taking 4 leaps and the deer is taking 5 leaps. Clear? Next information, 3 leaps of the tiger is equal to 4 leaps of the deer. So we know that 3 leaps of the tiger is equal to 4 leaps of the deer. This is what I want to find out. So we just need to put in the values of t or d, whatever, in order to get a ratio. So I can write t as 4 by 3d and then I can substitute it here. So it will be 4 into 4 by 3 divided by 5. The d gets cancelled, right? So it is simply 16 upon 15. So the required ratio of the speed is going to be 16:15. Option number D. Is it clear? So the first thing you should know is that I have been asked to find the ratio between the speed. So ratio between speed is going to be equal to the ratio of the distance if the time is constant. Now is the time constant here? Yes, because in the first line they are saying that the tiger takes 4 leaps for every 5 leaps of the deer. So in the same time, tiger is taking 4 leaps whereas deer is taking 5 leaps. So if I consider the 1 leap of tiger as t and 1 leap of deer as d, so the ratio that I want to find out is 4t by 5d. Another information given is 3 leaps of tiger is equal to 4 leaps of deer, that is 3t is 4d. Then it's just simplification and you can find out the ratio as 16:15. Alright, let us look at the next question, which is again from the topic of time, speed and distance. A and B are 2 stations 390 kilometers apart. A train starts from A at 10 am and travels towards B at 65 kilometers per hour. Another train starts from B at 11 am and travels towards A at 35 kilometers per hour. So at what time do they meet? Okay, easy question. Pause the video, give it a try and then you can play and cross check the solution that we discussed. So A and B are 2 stations which are 390 kilometers apart. So suppose this is A and this is B. So 390 kilometers apart, right? This is the distance between them. So suppose the name of the train is also A, just to make it easier. And it starts at 10 am towards B at 65 kilometers per hour. Okay. Another train starts from B. So again, I'm going to name it B. And this is starting at 11 am with 35 kilometer per hour. And I want to find out where they meet, right? Somewhere they're going to meet. So where are they going to meet, right? At what time do they meet rather? Suppose the meeting point is M, so at what time do they reach here? So in these type of questions, if the two bodies are starting at different times, like we can see here, this is starting at 10 a.m. whereas this is starting at 11 a.m. The first thing you have to do is you have to make the time equal. Alright, so we want to have the same starting time. Otherwise, we will not be able to proceed with the question, right? So here we have 10 a.m. and then B starts 1 hour later. So in this 1 hour between 10 and 11, A must have covered a certain amount of distance, right? So how much distance is A going to cover in 1 hour? We know that the speed is 65 kilometers per hour. That means it travels 65 kilometers in 1 hour. So at 11 a.m. it has covered 65 kilometers. Suppose at 11 a.m. this is where A is at this place called A dash at 11 a.m. and it has already covered 65 kilometers. It has covered 65 kilometers. So now at 11 a.m. this is where A is at A dash and B is at B, and now they are both starting and moving towards each other. So it's easier for me to find out at what time they're going to meet, right? So this is also 11 a.m. and what is the distance between them now? What is the distance between them? Initially it was 390 kilometers, but A has already covered 65 kilometers. So the distance is going to be 390 minus 65. This is what is remaining. So this is going to be 325 kilometers, right? So the distance is 325 kilometers. So this is simply, we now have two bodies which are moving towards each other, right? I have A here and I have B here, and I know the speed. This is traveling with 65 kilometers per hour and this is traveling with 35 kilometers per hour, and they're moving towards each other and they're going to meet somewhere, right? So this becomes a simple question of relative speed. The total distance they want to cover is 325 kilometers. I have the relative speed, two bodies moving towards each other. So I just want to find out the time when they are going to meet, right? So how do we do that? So the relative speed for two bodies moving in opposite directions is going to be 65 plus 35, right? We add up the speeds, that is equal to 100 kilometers per hour. And the total distance that they are going to cover is now 325 kilometers. So how much time? How much time will it be? 325 divided by 100 hours or 3.25 hours, right? 3.25 hours from what time? 3.25 hours from, remember we are now calculating from 11 a.m. We are calculating from 11 a.m. So 3.25 hours from 11 a.m. So what will it be? 12, 1, 2, right? So 2.25. 2:25 p.m. 2:25 p.m. Option number A. Is it so? Is it correct? No, it's not correct. Why? Because this 2.25 hours, we cannot just add this 2.25 hours with 11, right? I need to convert it into minutes and then solve. So 0.25 hours, basically quarter of an hour or 15 minutes. So basically I'm talking about 3 hours and 15 minutes, right? From 11 a.m. From 11 a.m. So 12, 1, 2, 2 hours and 15 minutes. So it is 2:15 p.m. not 2:25 p.m. So the answer is going to be 2:15, that is option number C, and not 2:25. Clear? So don't make that mistake. If you have hours in decimals, it does not directly become that many number of minutes. You have to convert it into minutes by multiplying with 60. Okay, clear? So this is a very simple question of relative speed. If you are able to break down and arrive at this point, if you can arrive at this point, then you will be able to solve the question very easily. Let us look at this question. It is from the topic of time and work. 2 men and 4 boys can do a piece of work in 10 days, while 4 men and 5 boys can do it in 6 days. Men and boys are paid wages according to their output. If the daily wage of a man is rupees 40, then the ratio of daily wages of a man and a boy will be what? So we want to find out the ratio between the daily wages of a man and a boy, and it has been given that the daily wage of man is 40 rupees and that men and boy are paid wages according to their output. So I want to find out the daily wage of a boy, and we also want to find out the output of the boys, right? So because the daily wage will be related to the output. How do I find that out? Based on the information which has been given, 2 men and 4 boys can do a piece of work in 10 days, and 4 men and 5 boys can do that same piece of work in 6 days. So suppose I take the work done in 1 day by 1 man, right? So work done by 1 man, or work done in 1 day by 1 man to be M, and the work done in 1 day by 1 boy to be B. Okay, so I have 2 men and 4 boys. So the work done in 1 day by 2 men is 2M and 4 boys is 4B. This is the work done in 1 day, and how many days are they working for? They are working for 10 days. So multiplied with a 10. This is going to be the work. Similarly, 4 men and 5 boys working for 6 days are also giving me the same output, or are also doing the same work, right? So we can equate these two. We will equate these two. What will we get? Let's see, is equal to 4M 5B into 6. Let us solve this. Basically, we will arrive at some relation between M and B, right? So this will be a 4M is equal to 10B, or I will have 5B is equal to 2M, or the ratio between man and boy, right? So M by B is going to be 5 by 2, right? So this is the work that is done by 1 man and work that is done by 1 boy. Ratio is 5:2. Now we also have been given that the men and boys are paid wages according to their output. So whatever is the ratio between the work done is going to be the ratio between their wages also. So this ratio between the work done by man and boy is going to be equal to the ratio of the wages that is paid to them. So the final answer, or the required answer, is 5:2 itself. There is no need to calculate the wage for the boy as such, because the ratio will remain the same, that is 5:2. So the required answer is option B, or 5:2. So this is the practice question for you. An aeroplane flies along the 4 sides of a square at the speeds of 200, 400, 600 and 800 kilometers per hour. Find the average speed of the plane around the field in kilometers per hour. The options are 384, 375, 432 and 221. So give this a try. Whatever answer you get, mention it in the comment section below, and we will be updating the correct answer in the first pinned comment in the next 24 hours. If you have any doubts regarding the questions we discussed in today's class, please feel free to comment below and I will definitely get back to you. I will see you in the next class. Thank you so much. All the best.